Ways to solve simultaneous equations. In this video, we're going to do a method called elimination, and in the next one, we're going to do substitution. So there's two different ways. And first off, a simultaneous equation is a pair of two equations that looks like this. So we have two variables in each one, and we have two equations. And we want to find out values of x and y that satisfy both of these equations at the same time. So that's what the word simultaneous means. Okay, now I've labeled this equation, equation 1, and the second one, equation 2. And it's important to keep track of what you're doing to each equation. Now, there's two things you can do to manipulate an equation. So you can multiply both sides by a number, or you can add or subtract equations together. So that's the only two things you can do to equations to manipulate them. And for us, we're going to look at solving them by elimination. So what that means is we want to eliminate one of these variables by, for example, adding the equations together or multiplying by a number. So we're eliminating one of these variables, x or y, it doesn't really matter. And then we just have an equation in one variable, which we can solve. Okay, so let's look at this example. We want to get two terms of a variable in both equations. So what we're going to do is take the second equation and we're going to multiply it by 3. So this is just to keep track of what we're doing. So we're taking the second equation, multiply both sides by 3. We get 3 times 3x is 9x. 3 times minus y is minus 3y. And 3 times 23 is 69. And I'm going to label this equation number 3. This equation has identical solutions to equation 2. We've just multiplied both sides by the same number, so we're not changing anything about the equation. And now you can see that in equation 3 and in equation 2, we have two terms involving 3y. So now what we're going to do is we're going to add equation 1 and equation 3, and then the 3y terms are going to cancel out. So I'll just write this over here. We're going to add equation 1 and equation 3. So we have to add the left-hand sides together and the right-hand sides together. So if we add 2x plus 3y, this is from equation 1, and we're going to add 9x minus 3y. And then on the right hand side, we're going to add 8 and 69 together. And this simplifies as 77. Okay, so now the 3y's are going to cancel out. And we've just got an equation involving x's. So let's collect the terms. We have 11x on the left-hand side, and we have 77 on the right-hand side. And now this is just going to solve by dividing both sides by 11. We're just going to get x is equal to 7. So this is half of the solution. Now we also want to know what value of y that corresponds to this value of x that also solves both equations. So all we need to do is substitute this value of x into either one of these equations. It doesn't matter which one. We're going to go for the second one because there's only one coefficient of y, and that's going to make it a bit simpler. So let's go up here, and we're going to substitute x is equal to 7 into the second equation. So I'm just going to write substitute into, just to keep track of what we're doing. and we're going to get 3 times x. X is 7, then minus y. That's what we're trying to find out, and this equals 23. So if we just solve this, we're going to rearrange for y. Let's add y onto the right-hand side and subtract by 23. So 3 times 7, which is 21. Subtract by 23 on both sides, and add y onto the right-hand side. And then 21 minus 23, that's just minus 2. So we get that y is equal to minus 2. And this is the second half of the solution. So together, x equals 7 and y equals minus 2. This forms the solution of this pair of simultaneous